Hi there guys, this is Don from Prana-Tech. So today's video I'm going to show you how to build a spot welder from a transformer in a microwave. The transformer that they put in a microwave is an extremely powerful transformer, and it's great for making spot welders. It's big enough and it puts out enough amps. In fact, one of the things we have to do is kind of step it down in amperage so that we can make it so it doesn't burn right through things like, you know, the thin wall of the top of the 18650 batteries, which is mainly what I'm building this spot welder for, is for making battery packs and welding together 18650 lithium ion batteries for making my own battery packs and things like that. So I'm going to show you basically how I built this spot welder, and then I'm going to show you a safe way to weld your batteries together. It's actually the method that Tesla uses in their cars for welding together their 18650s, so they're actually fused, and that if one cell goes bad, it doesn't chain reaction and burn the whole car down. So what I'm going to show you is how to build it, and then how to use it, and how to weld it together. So stay with me and I'll show you how I built this. Alright. Okay, the first thing you got to do is find an old junk microwave. Luckily, I have enough friends that know that I do weird things like this, and they call me and say, hey, it's an old microwave if you want it. And so I generally don't have to ever pay for one. So here's an old junk microwave that I was given, and so I have no money in it. I'm just going to tear it down now and get down to the transformer. Basically, you have to just take off all the outer covers, strip it down, and when we get a little bit closer, I'll show you how to discharge the capacitor. Okay, enjoy. Alright, we're going to slow things down here just for a second, and we're going to go over some safety stuff. You see the pliers on the bench? See how the handles are insulated? This is very important. This is a safety issue, and we have to discharge the capacitor. You'll notice there is a sticker right there that says danger. They're not kidding. And a charged capacitor inside of a microwave can have up to 2,000 volts in it. It's a very dangerous thing. So it's not dangerous to discharge it. All you do is take your insulated pair of pliers and hold it by the insulation, and then use the tip of it to basically ground the two poles on the end of the capacitor. You'll see the capacitor over there to the left. See those two sets of poles on the end of it? Well, we're going to reach in with our pliers, and we're just going to touch the end of them together so that it makes contact and shorts out the capacitor. Once you do this, the capacitor is like just a piece of metal at that point. It's not dangerous anymore. Anyway, that's the only real dangerous thing that you have to worry about if you're going to take apart a microwave, is that capacitor holding its charge. You'll also notice that I had already removed the wires from the capacitor. I did that with the same pliers, insulated handle pliers. That way there's no chance of the power going into the transformer. So before you get going, you want to reach in, pull the wires off of the capacitor. And right now I'm just removing all the wires from the transformer as well. So I couldn't get a good camera angle to show you how to discharge the capacitor while the wires were still on it. I had to remove the magnetron piece that actually makes the microwave before you could see the capacitor. But normally what you'll do is take off that magnetron, get in there where you can see. You'll pull the wires off the capacitor and then you'll discharge it like I just showed you earlier. Anyway, I'm just down to the last little bits here, pulling off the bolts that hold the transformer, and then I'm going to take it out, and then we'll take off the large coil that's on the top there and leave the bottom coil. I'll show you that once I get it all disassembled. So once you get your transformer out of the microwave, you will see that there's two coils of wires. One wire is a much thicker wire, and that's usually on the bottom, but I have seen these transformers have them sideways. So you'll see that if you paid attention while you were taking apart your microwave, that one of them is hooked up to 110 volts, and the other one that has the really fine wire is the one that goes out to the capacitor and out to the microwave generator. The one we're going to need to remove so that we can turn this into a spot welder is the one that has the really fine wire. You can see right here that it's a very small wire, somewhere around 10 to 12 thousandths of an inch. And that's the wire we want to remove. So what most people do is they'll come in with either a hacksaw or a cutoff wheel, and they'll cut across the face right here. The only thing, it doesn't really matter. You're just getting rid of the copper. You just need to cut the joint, because once you get this cut off flush, you can tap the copper out the other side both ways once this piece is off. I've also seen a really slick way somebody has done is take a wood chisel, and they sharpen it, and then they come down from the top and chisel these two pieces straight through. The only thing you have to be careful of is not to damage the coil below it. Some guys put in a little piece of wood or plastic so that when the chisel goes through, it doesn't cut into the next coil. We just want to make sure this one's left intact and that we have an open channel going through the transformer. So once you get that done and get your upper copper, your fine wire copper, out of the transformer, then you can start turning this into a spot welder. This is the one that I have that I made into the spot welder. You can see that the 110 volt inputs are right here. The only thing I've done is split it off for one of the legs, the hot leg, and I've attached a foot pedal switch. This is just a momentary contact switch. It is a Temco that I got through Amazon, and I will put that in the description, a link for it. And this was, I believe it was either $10 or $12 when I bought it. This is basically how I control the pulse. And this is a really simple system. Basically, you have to just experiment and work on your pulse. For when you press the button, it'll do the spot weld. And that's how I do it. So now that you have electricity coming in to your coil, and then you have your switch that controls the voltage going through, we then have to wrap the upper section of the transformer. So what I've done here is I've put 3 wraps through the upper coil section, and I've made a much simpler coil. So this is number 10 wire that I've wrapped in the upper section. It is approximately 3 millimeters if you're outside the US and need metric measurements. But 10 gauge wire is what I used, did 3 wraps, and then this is what's going to connect to the spot welder so that the amperage can go out through to the batteries. I've played around with a bunch of different diameters of wire and wraps, and the more wraps you do, the lower the amps and the higher the voltage. The fewer wraps you do, you have higher amperage and less voltage.
I actually have another one that I've been working on that is going to be a full-size spot welder, and that only has one wrap through it, and that has 1 gauge wire. So in this case we're using 10 gauge wire, and this is what we're going to use to power the spot welder. So you can see that I screwed the transformer down to a piece of white plastic. I wanted something that was non-conductive, and I had this thing around from an old RV water tank that I had in the garage. And so I cut that tank up, and it's about 3/8 of an inch thick, and it makes a great base for setting on my desk or my workbench. So the next thing I needed was some way to convey the electricity out over the battery pack. So I actually found a copper bus bar that came out of a computer mount, and it's 1/4 inch thick by 1 inch wide, and it was about 18 inches long. So I cut it in half, and so I've got about 9 inches of length, and I sandwiched it between another piece of plastic that I had of this same stuff. So you can see that it's 2 copper 1/4 inch plates, with sandwiched between it is a isolator of plastic. I then made a pivot. I drilled through both sides and put a plastic rod through the center. This gives me a pivot that I can mount the copper bars to, and then down here I just put a plastic nut and screw through it so it'll hold it together. That way there's no conductivity between the 2 sides. On the bottom you can see that I have drilled and tapped the face of it, and here I have my 2 electrodes that I have made just out of some 2mm or 80 thousandths solid copper wire. I just bent them basically like an S so that they would come out a little bit and be out in front of the welder so I could see what I was doing. These are replaceable, so if they get burnt or wear out, I can just pop them out with an Allen wrench and put new ones in. So I also needed a mount for this, so I made 2 L brackets for holding the copper bar. These I'm going to screw to the top of the transformer, and it's going to hold the copper bars and allow it to pivot up and down. Alright, I'll show you how that looks as I put it together. As you can see, I put another plastic bar across the top. This was going to be for where my spring's going to attach to raise and lower the bar so that it returns to its original position. Now we have a pivot point for our bar, and I made a screw attachment right here on the top of the bar into the plastic so that there's no conductivity to the housing. And then I basically just took a spring, attached it to the top bar, And then all I have left to do is to attach the contacts from the coil wires. Okay, there it is. It's all ready to weld. Okay, so let me show you my technique for welding the batteries together. Here you can see I've made a small battery pack of 8 batteries, and what you're going to need to do this technique is you need some battery welding strap. They sell this on eBay or Amazon. You can find it everywhere. This is 8mm wide is what I use because it's just about the right width for the top of the battery. I then take a pair of scissors. I have an old set of crab claw cutting scissors, and it's they're kind of serrated on the edge, so it's really good for welding strap for cutting it. So what I do is I cut about a square about 8mm wide. And that sits on the top of the battery. And what we're going to do is we're going to weld a fuse wire. It's probably going to be kind of hard to see here, but this is a 10/1000 thick piece of nickel-plated wire. This is also can be found as what's called fuse wire. What you're looking for is to make a fusible link between each battery. You don't want to just do like a lot of battery packs that you see where they just weld the strap right straight across the battery. That's a really bad practice because, and you'll see a lot of batteries out of China that are just welded like that. Because what happens is if one of the batteries overheats during use, if one of the batteries shorts and overheats, it can start a fire. And what happens is you get a chain reaction. One battery goes and it sends the next one, and they catch fire. If you have a fusible link between each one, like Tesla does on his cars, then you don't have a chance. If one battery shorts, this fusible link, this small wire, burns through, and the connection to all the other batteries is done. So it can't charge anymore, and it can't send voltage, shorting voltage, or I should say just a short, to the other batteries, which is what we don't want. If one battery goes bad, we want to isolate that battery, and that's what this system does. This fusible wire burns through, and then it isolates that battery, and then all the rest of the batteries can continue on. In a case of a small pack, a lot of times you may have to replace that battery and put in a new one and put in a new fusible link. But in a large battery bank where you have rods going down in between each group, basically the wire fuses from battery to battery and goes across the rod, and most people will solder to the center bus bar is what they call it. So what I'm going to do is show you how I do it. I take one of the little tabs and I lay this wire across the top because it's oversized and it's long and it gives me something to hold on to. And then I hold the wire in place, I lay the welding tab on top, and then I put it underneath the electrodes. So what I do is hold down tightly on the welder to hold the tab in place, and I have the wire going between the two electrodes, the fusible wire, and then I just give it a light tap with my toe. You'll hear it weld, then you can pick up off of it and then check your weld. Looks good. I flip it around, put another tab on, and once I have it so it looks good, press down on the spot welder, tap it, weld it, pick up. I'm going to zoom in here so you can see what the welds look like. Alright, I can give you a close-up here. You can see how it looks. You can see I got one weld on either side of the wire. And the wire is locked underneath there. Once it's pressed down and welded in, it has great contact all the way across underneath. I then take the wire, fold it up over on both sides, pull it back over, and then what I do is I trim it right there, just flush, and then push it down so it doesn't poke anything. Anyway, let me trim this off and then I'll show it to you finished. Okay, so there I trimmed off the fuse wire, folded the ends over onto the top, and now we have a fusible link between our two batteries. If you needed a bus bar down through the middle, you just lay it down through there and attach it to your battery holders, and then run your fuse wire over the top of it. And I do this, I don't have to, I pull it tight after I do the first weld. I pull it tight when I do the second one down over a bus bar, like a solid piece of copper wire or something like that. And then when I weld, it pulls everything tight, and I don't have any soldering to do, because that's one of the reasons I started doing this, is I didn't want to solder batteries anymore because I seem to be having some get damaged. This is a much cleaner, much faster, no fumes, no smell or anything from all the soldering and all the heat that damages the batteries. Okay. So a lot of people have asked me, why would you build your own spot welder when you can buy a spot welder on eBay or Amazon for doing the exact same thing? Well, that's an interesting question. One of the reasons is that I really like to build things. I enjoy projects, and I like to take old things like an old microwave that gets thrown away and recycle some of it. If we can recycle things and turn them into useful tools that we can use in everyday life, why not? Saving this stuff from going in the landfill, I think, is a great idea. The other thing is that everything in this I had in my garage, and I built it for free. The only thing that cost me any money was the foot pedal to do the switch. Everything else was leftover parts from things that I recycled. And so I basically built a spot welder for $10 or $12. And the ones on eBay start at $95 to $100 and go all the way up to $300. And I would rather spend that money on something for my family, or something, you know, that's lasting, like a tool that I'm going to use every day instead of just once in a while. How many battery packs are you going to do unless you're building a solar array? So that's the reason why you would want to build your own 18650 battery welder. So that's pretty much it for this video on how to build your own 18650 welder for welding battery packs. I hope you enjoyed the technique on how to do Tesla's fusible link for safety with the lithium-ion batteries. And if you have any questions or comments, I'd love to hear from you about this style of battery welder, or anything else for that matter. Put it in the comments and I'll get back to you. And if you like my videos, if you want to see more of this, hit the subscribe button and the bell so you get notified when I come up with new videos. And I thank you guys for watching, and have a great day.